Section 5-6, Part 2, using linear equations in the slope-intercept form. The line models the relationship between a temperature in degrees Celsius and degrees Fahrenheit. So let's look at this table that we have been given. It's Fahrenheit versus Celsius. You see on the x-axis you have temperature, degrees Celsius. Every little marking is representing 10, 20, 30, 40, and so forth on. You have your vertical axis, which is the temperature in degrees Fahrenheit. You see every little marking represents 25. So 25, 50, 75, 100, and so forth on. So let's look at A part. A part says, what is the y-intercept of the line? A part. What is the y-intercept? Well, where does this graph touch the y-axis? Where does my line touch the y-axis? Well, it touches it at this point. Well, you see the name of this point is 0, 32. So 32 would be your y-intercept, because it's asking where does the graph touch the y-axis when it's asking you for the y-intercept. Now let's look at B part. B part says, what is the slope of the line? Well, you have the point 032 has been given. You have the point 104 has been given. So we will use these 2 points to help me determine the slope. So I have 32 as a point, and then I have the point 104. 104. So let's find our slope. Subtract the y's. 104 minus 32. 104 minus 32. Subtracting the y's in the numerator when you're finding your slope. Next, subtract your x's. 40 minus 0. 40 minus 0 in the denominator. So use your calculator. 104 minus 32 gives you 72. And 40 minus 0 gives you 40. Now we can reduce this fraction. Actually, 8 will divide into both of these numbers. I could start reducing by 2, continue reducing until you no longer can reduce anymore. But 8 is the largest number that will go into both of them. So 72 divided by 8 gives me 9, and 40 divided by 8 gives you 5. So the slope of this line is 9/5. Now let's look at C part. Write an equation for the line where x is the temperature in degrees Celsius and y is the temperature in degrees Fahrenheit. Okay? So to do that, we will use that slope-intercept form of the line. So for C part, we will use y equals to mx plus b. So let's fill in. We know our m, our slope, was 9/5. So I have 9/5 x plus our y-intercept was A part, that's b, so I use plus 32. So that's the equation of the line. Now, D part. Let's look at D part. D part says, use the equation to find the Fahrenheit equivalent for 18 degrees Celsius. Use the equation to find the Fahrenheit equivalent for 18 degrees Celsius. Now remember, x is the temperature in degrees Celsius. So if we are given degrees Celsius, we will need to plug it into x because x represents degrees Celsius. So using our equation, y equals to 9/5 x plus 32, we are going to plug in 18 degrees Celsius in for x. Okay, so we're going to plug in 18 degrees Celsius into x. So I have y equals 2 9/5 times 18 plus 32. So you have 9/5 times 18. All right? Now think about it. 18's over 1. So you can multiply those fractions straight across. Take your calculator. 9 times 18 gives you 162. 5 times 1 gives you 5. You must multiply first. Multiplication comes before addition in the order of operations. So you must multiply these two fractions first, straight across. And you get 162 divided by 5 plus 32. Now we can change that fraction to a decimal. 162 divided by 5, if you punch that in on your calculator, you will get 32.4 plus 32. Continuing on your calculator, 32.4 plus 32 gives you 64.4. So, this is what we found out. 18 degrees Celsius is equivalent, which means equal, to 64.4 degrees Fahrenheit. So we determined that 18 degrees Celsius is equivalent, which means equal, which means the same, as 64.4 degrees Fahrenheit.